students, I am Nilanjana Sanyal, an online math tutor from India. I tutor students of the IB and the IGCSE boards from grades 9 to 12. This is my website www.nsonlinemathtutoring.com. You may visit my website to know about my tutoring services in more detail. Okay. Now we are solving questions from the topic geometric sequence, and this is our 6th session on this topic. In this session, we will be taking up 2 word problems in which we will be having both the properties of the geometric sequence and the arithmetic sequence. Okay. In fact, this is the second last session on this topic, geometric sequence, and we will be having another session, that is the 7th video session on this topic. And in these last two sessions, we will be covering 4 word problems which are dealing with both the sequences. Okay, not only a single geometric sequence or geometric progression properties, but they are dealing with the properties of both the arithmetic sequence and the geometric sequence, or the arithmetic progression and the geometric progression. Okay, so let us start with the very first question of this session. A geometric sequence with the common ratio r and an arithmetic sequence with the common ratio d have the same first 2 terms. Okay, so first 2 terms. Okay, so let us form the corresponding mathematical equations. So for the geometric sequence and the arithmetic sequence, the first term is the same. Therefore, let us write the first term to be, okay, this is the arithmetic sequence and this is the geometric sequence, and the first term. Let me take the first term as A. So if it is the first term for the arithmetic sequence, it will be the first term for the geometric sequence as well. You may take U1. Okay, I am just avoiding the subscript, so I have taken A. The second terms are also the same, so what will be the second term for the arithmetic sequence where the first term is A and the common difference is equal to D? It is A plus D. Okay, A is equal to A. Okay, fine. And A plus D is equal to the second term of the geometric sequence is AR, because the common ratio is R and the first term is A. So A plus D is equal to AR. This is the most basic equation. And A plus D is equal to AR. This is the second equation. Okay. Now the next information that we collect from this question is the third terms of the geometric and the arithmetic sequences are in the ratio 2:1. So it is third term of the geometric sequence, term of geometric sequence over third term of the arithmetic sequence is equal to 2:1 or 2/1. Okay. And what are the expressions for these terms? Third term of the geometric sequence will obviously be equal to AR square. And what is the expression for the third term of the arithmetic sequence? It is A plus 2D. So this should be equal to 2/1. So we are having 3 variables A, R and D, but effectively this is our third equation. So we are having 2 equations. but we cannot stop. We will be continuing, and let's see how far can we proceed. We have to give the possible values of the common ratio r. Okay, so it is AR square is equal to 2 times A plus 2D will be equal to 2 times A is 2A and 2 times 2D is plus 4D. So this is the equation that we get after cross multiplication. Okay. So what we can do is, I can find the value of D from this second equation in terms of A and R. So this will be AR minus A. Okay. D is equal to AR minus A. Now I just substitute this value of D over here. It becomes AR square is equal to 2A and it is 4 times D. So it will be practically 4 times AR minus A. So 4 times AR is 4AR and 4 times minus A is minus 4A. Okay. And now we see that we are having the variable A present in all the terms. So I can divide the entire equation by A. Therefore, I have the equation as R square is equal to 2A divided by A is 2 and 4AR divided by A is plus 4R and minus 4A divided by A is minus 4. So R square is equal to 4R minus 2. This is a quadratic equation, so I am writing the equation over here. Now we have to solve for the value of R. Okay, so R square minus 4R plus 2 is equal to 0. And I would be preferring the quadratic formula to get the value of R. So R is equal to minus 4, so it is minus B becomes plus 4 plus minus under root 4 square is 16, or rather negative 4 square whole square is 16 minus 4AC, 4 times 1 times C is 2. So this is over 2 times 1. So R is equal to 4 plus minus 16 minus 8 is 8. Okay. Over 2. So this is equal to 4 plus minus 2 root 2. 8 can be written as 2 root 2 over 2, which is equal to 2 plus minus root 2. Okay. These are the two possible values of R. R can be equal to 2 plus root 2 or 2 minus root 2. Okay. These are the two exact values. If you want, you can convert this root 2 to a decimal number. That will be an approximation. So it is better that you give it in such form. The two possible values of R will be 2 plus root 2 and 2 minus root 2. Okay. So let's write the answer. R is equal to 2 plus root 2 or R is equal to 2 minus root 2. Okay. We have seen that there were 3 variables A, R and D, but we had only 2 equations. So we could not find the numerical values of all of them, but we have indeed found the numerical value of r. Okay, so now let us move on to the next question. An arithmetic and a geometric sequence both have the first term as 1 and their second terms are also equal. So this is a similar question. Okay, first of all, let me read this. So arithmetic sequence and geometric sequence. Again, I am repeating, you may call them as arithmetic progression and geometric progression. Okay, so the first term is 1 for both of them, and the second term for that, let me write the, for arithmetic sequence, common difference equal to D. Okay, just a moment. Equal to D. And for geometric sequence, common ratio is equal to R. So now the second term of the arithmetic sequence becomes 1 plus D, and for the geometric sequence it is 1 times R, which is equal to R. Okay, so these two are equal. I am not writing 1 equal to 1, it is very obvious. So 1 plus D is equal to R. And the next information that they are giving is the 14th term of the arithmetic sequence. What is the 14th term? It will be U1, that is the first term, which is 1 plus n minus 1, 14 minus 1, which is 13, D means is equal to 3 times. So 3 times the third term of the geometric sequence. What is the third term? It is 1 times R square. So it is R square. Okay. So 1 plus 13D is equal to 3R square. So this is the, let me write this to be the first equation, and this is the second equation that we are having. And they are asking us to find the 20th term of each sequence. Okay. So, okay, fine. Let us substitute the value of R, which we are getting from the first equation. R is equal to 1 plus D. So we may write 1 plus 13D. 1 plus 13D is equal to 3, 1 plus D whole square. Okay, because R is equal to 1 plus D. So 1 plus 13D is equal to 3 times 1 plus 2D plus D square. I am using the algebraic identity. You may just multiply 1 plus D times 1 plus D. You will be obviously getting the same expression. So 1 plus 13D is equal to 3 plus 6D plus 3D square. And now we see that this is a quadratic equation involving the variable D. So we may find the numerical value of D. So let us find the numerical value of D. It is, if we just rewrite and bring all the terms to one side, we get 3D square and then 6D minus 13D. It will be negative 7D. and 3 minus 1 is 2. So plus 2 is equal to 0. Okay, and so this can be written as 3d square minus 6d minus d plus 2 is equal to 0, or 3d d minus 2 and minus 1 d minus 2 is equal to 0. Okay, therefore d minus 2 or 3d minus 1 is equal to 0, giving us the numerical value of d as 2 or 1 over 3. Okay, so now we come back to this equation, the first equation. 1 plus d equal to r. So when d is equal to 2, r is equal to 1 plus 2, which is equal to 3. Okay, and when d is equal to 1 over 3, r is equal to 1 plus 1 over 3, which is equal to 4 over 3. Okay, now they are asking us to get the 20th term of both the sequence. And we know the first term is 1. So the first term is 1. Therefore, 20th term of the arithmetic sequence. We will be having two cases. When d is equal to 2. So, 20th term is u20. u20 will be equal to 1 plus 20 minus 1, that is 19, times 2. So 19 times 2 is 38 plus 1 is 39. Okay, and when d is equal to 1 over 3, 20th term, which is u20, will be equal to 1 plus 19 times 1 over 3. Okay, which is 19 over 3. And this 1 can be, I can write this as 3 over 3. So 3 over 3 plus 19 over 3 is equal to 22 over 3. Okay. So this is equal to 7 and 1 over 3. Okay. So this is the 20th term of the arithmetic sequence. When d is equal to 2, the 20th term is equal to 39, and when d is equal to 1 over 3, the 20th term is equal to 7 and 1 over 3. So this is a big answer. I cannot write at the top. I am just boxing it. It's not the sports boxing, just I have made an outline. This is the 20th term of the arithmetic sequence. And coming to the 20th term, let me write over here. Let me get the 20th term of the geometric sequence. Again, we will be having two cases. When r is equal to 3. U20 will be equal to 1 times 3 to the power of 19. Okay. Now, if it is a paper 1 question, then obviously this will be equal to 3 to the power of 19. And even if it is a paper 2 question, I am just showing you what is 3 to the power of 19. It is a large number. So it is 3 to the power of 19. Okay, so this is equal to, you see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. It contains 10 digits. It is a large number, so it is very natural or it is totally correct if you keep it as 3 to the power of 19 and don't write the value. Okay. So this is the value of the 20th term when r is equal to 3. And what is the value of the 20th term when r is equal to 4 over 3. U20 will be equal to 1 times 4 over 3 to the power of 19. Now let us see whether we get a large value or a manageable figure. Okay. So it will be 4 over 3 to the power of 19. So 4 over 3 and then to the power of 19. It is manageable, 236.503. So we may write it as 236.5. So this value can be written. It is 236.5. Okay. So for the geometric sequence also we have got the 2 different cases, and these are the 2 different values for the 20th term where r is equal to 3 and when r is equal to 4 over 3. Okay. So students, this brings us to the end of this session. We have solved 2 word problems containing both the geometric sequence and the arithmetic sequence properties. And our next session will be the last session on the topic geometric sequence, and it will also be containing 2 word problems which will be dealing with both the geometric and the arithmetic sequences. So please do not miss that session. Okay. Thank you for watching this session till the end. We'll be meeting very soon in our next video session. Please give this session a like. Please give this video a like if you found it useful. Please subscribe to my YouTube channel and do not forget to press the bell icon. You'll be getting notified as soon as I publish a new video. Okay? So bye for now.